Okay.
Yeah, I would just go to
Let's see here. Using one trigonometric ratio to rule them all. Come on, where are my Lord of the Ring fans out there? Seriously. Okay, all right. Okay, good. All right. Let theta be an acute angle such that sine of theta is 5, 6. Okay, so we got a right triangle. And we got theta down there in the corner. We are told that one of the sides of this triangle is 5 and one of them is 6. Which one of the triangle sides is a 5? Right. Opposite hypotenuse, right? So the opposite side would be 5 and the hypotenuse would be 6. That's the only way you get a sine to be 5, 6. Okay? And make sure you're following along on the notes instead of trying to do math Excel assignments. Not sure anybody would be doing that. But okay, so how do I find the last side? Pythagorean theorem, right? Now, hopefully you, at this point of your life, you know your Pythagorean theorem well enough, your a squared plus b squared equals c squared, that you could work backwards quickly. I really don't, do I need to spell it out, or if I do square root 6 squared minus 5 squared, will you be okay? Do you understand that I'm using the Pythagorean theorem? Okay. So square root of 36 minus 25 is what? Square root of 36 minus 25. 11. Okay. You know, ironically, somebody said 3 last period too. That was the first thing out of their mouth. I was like, 3. And then it happened again. I got to think about that. I don't know. I'm not sure where that came from.
I think they're going to get confused with the
Oh. Maybe. You've never heard of a Pythagorean triple? No. A Pythagorean triple means that the values are all integers. And for those of you who don't know this, the most famous one is 3, 4, 5. Now, every multiple of 3, 4, 5 is also a Pythagorean triple, such as 6, 8, 10. The reason I bring that up is it shows up on the ACT and the SAT. You look at one, somewhere in one of your tests on those days, a 3, 4, 5 triangle shows up. Yeah, at least once. And so if you see that, maybe it's, 3, 4, 5, what do you got there? If I multiplied everything by 4, 12, 16, and 20. Okay, so that's an example. And I've seen that show up in a question. And if you recognized it, it made the question really easy. And if you didn't recognize it, you probably wasted a whole bunch of time. In fact, I'll try to dig that question up for you because it goes along with right triangle stuff. So that would be useful to us. Okay, so now they're asking me to find the other 5 trig functions. Okay, let's see here. I'll zoom in a little bit to give myself some room. So we've got the sine. Well, if we've got this sine, what other trig function should we look at first? Probably its reciprocal. What's the reciprocal of the sine function? No. What is the name of the reciprocal trig function for sine? Starts with a C, that's true. Cosecant. Right? We said that it started with the opposite letter. And the cosecant, you guys all said, was 6 over 5. Okay? So now we need the cosine of theta and the tangent of theta. What's the cosine? How about adjacent? Let's see if I can switch colors here. Right, this would be your adjacent side, this would be your opposite side, this would be your hypotenuse. So what's radical 11 over what? 6. What about your tangent? Opposite over adjacent, right, TOA. Okay. Yeah, 5 over radical 11 does rationalize to 5 radical 11 over 11. That's true. Now, I have a reason why I wrote this over here, and I'll show you why in a minute. So what's the reciprocal trig function for cosine? Secant. The secant of theta equals, and then what were you going to say? Okay, so 6 radical 11 over 11. So she rationalized it in her head. She flipped it over and then rationalized it. Okay, which reciprocal trig function goes with tangent? Cotangent. Now, the reason I wrote this down over here is because that's going to be the easier one to flip over. What is it? What is it? Radical 11 over 5. So if I take the unsimplified one of tangent and flip it over, I get what I need for cotangent. Yes? Sure. Oh, that's fine. That's a good question. Okay. Let me switch to a different color. So let's take this one right here. When we flip it over, we get 6 over radical 11, right? So to rationalize it, we would multiply by radical 11 to the top and the bottom. So what happens on the bottom? I get 11, right? Okay, so that's where we ended up with this thing over here. Did that help? Okay, good question. Folks, when I was in a college math classes, I mean, you know I was a math major, right? Yeah, you hope so. Every single math class I stepped into college, I felt like I was the dumbest person in the room. And every time I walked out of that class, I realized I was not. But here's why I felt that way. Because I was the one that was asking all the questions. Don't be afraid to ask the questions, because that's how you learn. Okay? I'm going to go off here for a sec. So keep asking those questions. Those are good ones. I like it. All right, let's see. What else do we have here? Okay, now you need your calculator for this part right here. And let me see where my cool camera is here. Get it hooked up. Let's get this open. Come on. Alright, let's zoom in on this. Alright. Go to the mode button right here, next to your second. I call it the Edna button. Edna mode. Thank you very much, my incredible fans out there. All right. Make sure that your calculator is switched to degree mode. Degree mode. You do not want it in radian mode. Okay. You are a nice person. Yes, you are. Yes, thank you. Thank you. Next.
Can we listen to the song?
No, not that. Not at the moment.
After
class. After class.
Yeah,
What?
Does it matter if I'm in like A plus BI?
No, no. You just need to make sure you're in degree mode for that, between degree and radian. Okay. Type on your calculator cosine 30. And hit enter. Cosine 30, hit enter. Does it look like that? 0.866. Okay. All right. To me, this is a hilarious example. Let's look at what they actually say here. As you see in figure 4.16, the calculator gives the answer, blah, blah, blah. However, if we recognize 30 degrees as one of our special angles, we might recall that the exact answer can be written in terms of a square root. Okay. We square our answer. Who the heck is going to know that they should square this answer? That they're supposed to take the square of that value and come up with 3/4? I don't think any of you would know that. Yeah, but I don't think a lot of you are going to see that right away. So I thought that was kind of a dumb thing for them to say. Now, what I think is going to be more useful to you next week is for you to look at these 4 numbers. And then I'm going to take the square root of those numbers. And then I'm going to divide them by 2. Those numbers all go in order. Can you reduce the first one? What is the first one? More commonly referred to on the street as. I mean, folks, people at parties don't say the square root of 1 over 2. What do they say? How about 1/2, right? We already know the square root of 1, right? Okay. Does the second one reduce or not at all? Huh? Radical 2 over 2. Does that reduce or not at all? Not at all. Thank you very much. How about this one? Does it reduce or not at all? Not at all. How about the last one? That is the whole number 1, folks. These 4 numbers are going to be important to you. Do you know the decimal version of 1/2? 0.5. I'm sure you don't know the next one, 0.707. I'm sure you don't know the next one, 0.866. But you do know the last one at 1. They go in order. Those numbers are going to be important to you next week. Okay? More so than they are right now. Make sure on these triangle questions you're leaving your calculator in degree mode. If you type the cosine of 30 and you get negative 0.73 and it doesn't make any sense to you, you might want to check the mode on your calculator to make sure it's not in something like radian mode. Okay, next. Get rid of that. A right triangle with a hypotenuse of 8. Okie dokie. Includes a 37-degree angle. Is it important to me whether I put the 37 in the lower left or at the top? No, it really doesn't matter. We need to find these other 2 sides. How do you think we should do that? All right, so which let's say we want to start with x. Let's say we want to start finding that one. Which trig function do you think I should use? Any thoughts back here? Cosine? Because I heard cosine over here too, so you guys agree. All right. Cosine of 37 equals adjacent over hypotenuse. How do we solve proportions? We cross multiply. Now I know you're going to say multiply by 8, and that's fine, but I need you to understand that we're really cross multiplying. And yeah, you're going to say, well, Mr. Staley, dividing by 1 really doesn't matter. I understand that part, but there are coming other problems where you're going to need to know that you're cross multiplying. some of you are not going to set up the question correctly. For instance, I had somebody answering a math Excel question. Where was it? Was it over here? No, it was here. I had somebody that was answering a math Excel question, and they did not set up the equation correctly. In fact, they didn't set up the equation at all. They're trying to do everything on their calculator. If you cross multiply this, you do what? 17 times 1, right? And then what? Divided by what? Yeah, folks, I understand you can do 17 times 1 equals x times sine 34. But you need to go one step further. You guys have done enough cross-multiplying in your life that you need to get that one step where you just go multiply, divide. You need to get that in your mind. Once you set it up correctly, then you multiply and divide. Well, so because they didn't write it down, they divided, they multiplied, and guess what they kept doing? How come Math Excel keeps telling me I'm wrong? Set up the... I'm confident that if you set it up, you can cross multiply it correctly. But if many of you just reach out for that calculator and say, oh, I'll just type it on the calculator. Well, and then you type it wrong. So make sure you're setting up the equation so that you can get it typed correctly on your calculator. Okay, so what did we come up with? 8 cosine 37. What did we get? Approximately 6.389. Something like that. That is a bad looking 3. I wonder if I could get... got rid of the whole thing. So what are we going to do to find y? I don't want to use the Pythagorean theorem, and here's why. Because you're going to have to use a rounded irrational number. Now, you could use the Pythagorean theorem. There's nothing that says you can't. It's just that you would be, you'd be playing around with the accuracy. So I would suggest you go back to your trig functions and pick another one, like sine 37 equals y over 8. Of course, you're cross-multiplying, same thing. 8 sine 37. And what do we get for y? .815. That's true. Make sure you're able to use your calculator to cross-multiply these problems. Any questions on that I should ask? Okay, so here's a story problem, same type of thing. I don't care, you'll be fine. Stop whining. Yeah, you want some cheese with that wine. Okay, so we've got a building, right? Yeah. Slow, but oh, yep, you got it. Okay. I'm going to describe to you, I have to come up front, so I'll have to pause the video here. Go! All right, so 65 degrees is this angle. It's the angle of elevation, elevation being from the horizontal up. If I were at the top of the building and I was looking out over the top of the building, this would be the angle of depression. So this would be the angle of depression. This would be the angle of elevation. Now, what do we know from geometry? That was a long time ago. We still learned it. These are parallel lines. This is a transversal. What did we learn? They're the same, right? Because they're alternate interior angles. Ugh. Stop barfing back there. You're fine. Okay? So we have the 340. Where does this go in our diagram? It's the bottom, right? It's the base. The distance from where we were standing to the base of the building is 340. Okay, so we want to find the height of the building. Which trig function should we use? Tangent, that's right. Tangent of 65 equals opposite over adjacent. Whoops, bad looking for. Looks like a job for cross multiplication. So what height did you come up with when you multiplied? Whoa. Whoa. Come on, 340, 10, 65. 340, 10, 65. 729.1. Just double check your numbers on your calculator. Did you find it? Find out what you did? Check your radians. You know what? Whenever I do these questions and all of a sudden I get a negative number and I'm like, what the heck? How's the building in the ground? You know, then I think to myself, oh, maybe I should check my mode on my calculator. Almost always it's the mode. All right, now, that's the end of those notes. Does anybody have any problems that they've posted over here in the document that I haven't gotten to? I'll go down to somewhere. Come on, keep going. Come on, why is this going so slow? Gee whiz. Trying to get it. Yeah, some of these questions were, why is it like, that's not. Yeah, we were doing questions like this, find the 6 trig function values given a triangle. You know, you're just using their different sides, flipping things over. So if they give you information, draw the picture. Okay, so I think those are all the questions that were in there. Does anybody have any questions that they want to post in there for me? Do you guys have any questions that you want to post in the document for me? Why did what? Did you post it in here so I could look at it? Why not?
Because it wouldn't load. Like I tried it first.
All right, let me see if I can pull it up. Number 5, you said? Okay. All right. Here, let me snip it. This was question 5. Sine of pi over 6. Does anybody know what pi over 6 is in degrees? Well, if you don't, then you should convert it using the handy-dandy method we taught you. Anything cancel out? Pi and the radians, right? So that leaves me 180 over 6, also known on the street as 30 degrees. So this question was really about what's the sine of 30 degrees. Now, in your notes, didn't we have a really cool handy-dandy triangle, a special right triangle that looked kind of like this? Okay, so you tell me what the sine of 30 degrees is. Sine, isn't that opposite over hypotenuse? Oh, 1/2. Nice job. Right? So use the special right triangle that we have. Okay? Now, you probably just need practice recognizing your radian measures. So I would suggest, now once you do this one time, you pretty much understand. Oh, by the way, if 180 is the same thing as pi, couldn't you just substitute that in there for pi and have 180 over 6? So there's 30, right? So if you're just kind of thinking, okay, 180 over 3, that's a 60-degree angle. 180 over 4, that's a 45-degree angle.
I didn't recognize.
Ah, okay, gotcha. All right, so let's try to,
I tried getting Pythagorean Theorem.
let me throw this in the document. Where's my cursor? There we go. Oh, well, good. Probably helped out, didn't it? No?
I mean, I already.
Oh, you already did it. Gotcha.
Yeah.
Anything else? Any other questions you want me to go over? Okay, I'll come around and just answer individual questions. If you post something to the document, get my attention. I can put it back up here on the screen and help out.